right, guys, we're going to talk about another transformation today. One of my faves, but kind of a trickier one if I'm being honest, which is rotations. So when I hear the word rotation, I think of a circle, like rotating around or spinning or turning, or kind of like I think of a clock. And we're going to do this on page 100 and 101. So if we want to turn to that one, like I've been doing all of these, we will save the stuff on page 100 for a separate video, all those examples. I'm going to start with you guys on 101. Okay, so another word for rotation is a turn or a spin, something like that. I like to say turn, but, or I think of like a clock, which is kind of a big deal with this thing. If I want to describe a rotation using the correct notation so that we can speak appropriately in math language, the way that I notate that a rotation has occurred is I put a lowercase r, uppercase R was already taken. And then actually there are two things that have to go down as your little subscript here in parentheses. The first thing that you have to let people know about is what you are rotating around. So like, what is the center of rotation? Which will be a point, like somewhere on the graph. And for our purposes, we are mostly just going to rotate around the origin. That's kind of the best place to rotate from because it's 0, 0. Once you start rotating from other points, we don't have really shortcuts to do that. So, and it gets way trickier. So we're not going to worry about that. The second thing that you have to tell people is how much you're going to rotate. So what are you rotating around? And how far are you going to go? And so because we're traveling in like circles, I don't know if this makes a lot of sense. I feel like it should. You have to specify degrees, like how many degrees you're going to travel. And the reason I say that I feel like that makes sense is because there are 360 degrees in a circle. But also, I feel like it could be weird because when we're talking about degrees, we're usually talking about angles. But you do kind of have that here because you're like creating a starting point and an ending point. So you are creating an angle. So the second number you're going to write down is how many degrees you have traveled. Now, the other thing that you don't really say but needs to be understood is that the direction you're going in. So if the degrees are notated right here without like a symbol in front of it, like it's a positive number, I know this makes us feel uncomfy, but you're actually traveling counterclockwise because everything in math truly travels counterclockwise. That's just more normal in math. If they put a negative in front of the degrees, then that means that you're traveling clockwise. Or sometimes if you're lucky, they will just specify, like they'll say the word clockwise or counterclockwise. So just read carefully. Hopefully it will tell you the directions. If not, they are implied by a positive number being counterclockwise and a negative number being clockwise. Now, I kind of overtook all this spot for corresponding parts, but like all of the other transformations that we've talked about so far, the shape that I start with should be identical to the shape that I end with. And again, for this one, I think probably the best place to start is right at the top and we'll work our way down. Okay, so if I'm looking at a graph, and I'm wanting to rotate, oh, I already have lied to you. I put a point right there. Let's not do that. We're going to change that to just the origin, 0, 0. So if I want to rotate around the origin 90 degrees, you know, there is a way to like count it out, but for these ones, it's always just easier to use the shortcut, truly. So we talked about these shortcuts in our Desmos here. Hopefully we found those shortcuts. Because I'm going 90 degrees and it is a positive number, I'm going counterclockwise. So this one here, and this is showing me that I need to swap them and change the first number. So A is currently at -6, 3. B is at -3, 4. And C is at -2, 1. If I take these through my transformation of 90 degrees counterclockwise, again, right here, this is showing me I need to swap and then change the sign on the first one, which is kind of weird and confusing because it shows Y, but like when I swap these, Y becomes X, but I still need to change that one. So A prime, if I swap and then change the first sign, there we are. B prime, if I swap and then change the first one, and then C prime, I'm going to swap and then change the first one. So counterclockwise, we swap, change the first sign. That's the way I kind of think about it so that I can do it all in one. And then I would want to go plot those points. So when I plot A prime, we're going to go to -3, -6, which just barely fits. B prime is at -4, -3, 1, 2, 3. And then C prime is at -1, -2. And then I reconnect and get my shape. And everything should remain the same. Same length, same angles, all that good stuff. Now the other thing that I do want to point out is kind of how to know that you're right. So if I go from the origin, because I'm rotating around the origin, and I connect a line to one of my points. So let's say I connect a line to C. If I then also connect the origin to C prime, the angle that I get between those should be 90 degrees. And I know that it is, like, by looking at it, but also because of the slope. Like, this is down 1/2, so -1/2 slope. And then perpendicular to that would be 2, and that slope is shown right here as a slope of 2. A kind of easier way to know that you're right is like our quadrants are split up into 90 degrees each. So since I've only moved 90 degrees, I've only moved one quadrant. So this shifted one quadrant over counterclockwise. So that makes sense and feels good. So lots of different ways to think about this to make yourself feel good about what you've done. Alrighty, trying this one here. We are going to do a rotation around the origin of 90 degrees. Oh my God, that's the same. Let's change it to 180. All right, so if I do a rotation around the origin of 180 degrees, again, I feel that it's just easier to use our little tricks. So this is the same triangle I just had, so I'm rewriting those pre-image points. And the shortcut that we hopefully found in the Desmos is that if I'm going to rotate 180 degrees, all I do is change both signs. So change both. I don't do a swap, I just change both the signs. So A prime will be 6, -3. Change the sign, change the sign. B prime will be 3, -4. Change the sign, change the sign. C prime, change the sign and it's 2, change the sign and it's -1. So you're just changing both the signs. You don't do any swappy stuff. Then we go graph. So A would be at 6, -3, or A prime rather. B prime is at 3, -4. 1, 2, 3, 4. I feel like I counted wrong somewhere. Yep, that was a 5. A should be here, not there. I could tell because they weren't the same distance away. Like this is sort of 1 and 3, and that's 1 and 3. So that's how I know I was wrong. Bad counter, sorry. And then C prime is at 2, -1. C prime. And then I'm going to reconnect all my points now. Now again, if I think about feeling good about what I've done, this guy has moved 2 quadrants, and 2 quadrants are 2 90s, so 180. Also, if I do like I did on the last one and sort of go to the origin and connect C and then C prime, it should make a straight line because 180 degrees is a straight line, and it does. So I feel good about that. The last shortcut that we have, I mean, there's kind of 2, is if I rotate counterclockwise 270 degrees, which is 3 90s, so 3 quadrants moved. We will swap the points like we did with the 90 degrees counterclockwise, and this one we change the second sign. So change the second sign. Now, I guess we could talk about rotating 360, but nothing happens. You end up right where you started, so that just is silly. Now, I also put that going 270 degrees counterclockwise is the same as just going 90 clockwise. So depending on which way they're telling you to travel, you don't have different rules to remember. If I go 3 quadrants one way, that's the same as going 1 quadrant the other way. You're in the same spot. So, and 180 one way or 180 the other way is the same thing. And then if I go 90 degrees counterclockwise, that's 1 quadrant, or 270 the other way, I end up in that same quadrant. So, alrighty, let's practice a few more. So if A is at -2, 3, and B is at 0, -1, and C is at 4, 2, to get my prime points, when I rotate around the origin 90 degrees counterclockwise, I have another trick to show you that I really like. It really makes sense to me as a way to remember all these rules, because they're kind of weird, like swap and switch. What do I do? Like which time do I do what? I always like to draw my little quadrant, and I start in the first quadrant, normal, x, y, and the one opposite of it is also normal. The 2 diagonals in the other direction get swapped. And then I just think about, if I'm in that quadrant, who's positive and who's negative. So in the first quadrant, everybody's positive. In this quadrant here, the first number is positive, but the second number is negative. Here, they're both negative. Here, the first number is negative, the second one is positive. And if I'm going counterclockwise, we're going in this direction. And so it shows me exactly what my rules are. So I really like this as a visual reminder about what rule I need to pick. So because I'm going to go 90 degrees counterclockwise, that's 1 quadrant. So this is my rule. I'm going to swap and change the sign of the first one. So swap, change the sign of the first one. Swap, change the sign of the first one. Which if you leave the plus in front, who cares? Just, it's fine. Swap and change the sign of the first one. And there you go. On the next one, if I'm rotating 180 degrees, that means I'm traveling 2 quadrants. So starting here, I go 2. It doesn't really matter where your original figure starts, like using this diagram, you just always start in the first quadrant. And then I go 2 because 180 is 2 90s, so I've traveled 2 quadrants. And so this is showing me that I just need to change the signs of both. So if I'm doing A prime on A, change the sign, change the sign. On B, can't really change the sign, change the sign. And then on C, change the sign, change the sign. 0, 0 is still the origin. It's just a less fancy way of saying it. And if now I want to go 270 degrees, that is 3 quadrants traveled counterclockwise. So I'm going to swap and then change the sign of the second number. So if I take A and swap it and then change the sign of the second number, 3, 2. B, I'm going to swap and change the sign of the second number, but I can't because it's 0. And then swap and change the sign of the second number. There you go. And last but not least, if I still rotate around the origin, but now I go -90, that means I'm going clockwise 90. So going back to my little diagram right here, I still started in the origin, but now if I'm going to go clockwise 90, I'm really here. So I can see that that rule is the same one I just did, the 270. So they're the same exact points. So 3, 2, -1, 0, and 2, -4. They end up in the same spots. So, all right, last but not least, if I'm already looking at the pre-image and image, and I need to figure out how they rotated, it's kind of not so bad, I feel like, because you kind of just have to count how many quadrants you moved. So like if I look at this one here, here is my pre-image, and it moved 1 quadrant clockwise or 3 quadrants counterclockwise. So I like to think counterclockwise. That just makes more sense in my brain. So I went 1, 2, 3, and that's 270 because that's 3 90s. So we did a rotation around the origin of 270 degrees. Now, another way that you can think about it is you could compare the points. So like point A currently is at -7, 1. A prime is at 1, 7. So when I compare these, I notice that I swapped them and then changed the sign of the second number, which this one, 270, does that. I feel like looking at them is a little bit harder to do, but I mean, that's another way to do it. For this one here, kind of doesn't matter where I start, they move 2 quadrants. 2 quadrants is 180. So rotate around the origin, 180 degrees. I promise you they won't rotate around anything other than the origin for what we're doing. And then lastly, this one as well is a rotation of 180 degrees because it went 2 quadrants. So there you go. And again, like if I want to check the points, I could do that. Like here, this R point is at 3, 4. And then R prime is at -3, -4. So again, I can see the only thing that happened is we changed signs, and the rule that does that is 180 degrees. So I know rotations can be a little bit overwhelming because there's so many rules, but we will practice a whole bunch more on the next video.